I'm Anil Kumar, and in this video we'll discuss upper and lower bound with the help of trigonometric functions. So we'll take up an example. Let us say a person is pulling a sledge, let's say. So let's say a person is pulling a sledge. So let's say this is the sledge and the person is pulling it. So when you pull, you apply a force at an angle. So let us say the force is being applied at this angle, right? Now in my diagram, I'll assume that the force being applied is approximately, let us say, let's give some number, right? So let's say 215 newtons. That's the force which is being applied. And let us say the angle which it makes with the horizontal is around, let's say 28 degrees. Okay, so that's the angle at which the force is being applied to pull this. This is a sledge for us. So what we are given in this particular case is force of 215 newtons applied at an angle of 28 degrees, right? So that is what is given to us. Now if I write the force as 215 newtons and angle as 28 degrees, what it means? It means that the above figures are correct to whole numbers, right? So they are rounded to whole numbers. Is that okay? Or nearest integers. So both are rounded to nearest integers. So I'm taking very simple examples here. The idea is to understand the concept, right? So I'm not specifically writing 215 newtons round to nearest integer. When I write like this, and if I don't write any other specifications, then we'll assume that this is the nearest integer, okay? Right. Now what do we need? We need to find the maximum horizontal force. Let's find, so we need to find maximum and minimum horizontal force. This is what we need to find. Now, when I say maximum or minimum horizontal force, then in our language of upper and lower bound, maximum becomes the upper bound and minimum becomes the lower bound, right? So that is what we really mean by upper and lower bound. Now horizontal component is the component which is along this ground, right? So let's assume this to be an even ground. So that is the component. Now this force, let me call this force as force F, horizontal. Let me write F of H, right? FH. This is my horizontal force. So in trigonometry, we know this component will be equals to, let us say this is the force F and the angle is theta for us, right? In that case, this force will be F times cos of theta, right? So this is what it is going to be, right? So force will be F times cos of theta. That is the horizontal force. Now we need to find what could be its maximum value and what could be its minimum value. So that's what we need to find. So now let's see how we can use the concepts which we have learned in finding upper and lower bound to get a solution to this question, right? So we'll again make our table. So in this table, we'll write down the possible values for the upper and lower bound of the two components we're talking about, or two parameters. One of them is the force, right? And the other one is the angle theta. Let me write angle theta as theta. What do we need to find? We'll need to find the lower value and the upper bound, right? For each one of them separately, correct? As far as force is concerned, we are rounding it to nearest integer. That means whole number, 1, right? So what do you need to add here? So as far as force is concerned, we need to add and subtract plus minus 0.5, right? That you get because you're rounding to a whole number, 1 divided by 2. That is how we get, right? So the force is 215. If you add 0.5, then you get a value which is 215.5, correct? And if you subtract, you get 214.5. Is it okay? The units will be, we'll write units as newtons. Okay. This angle is in degrees. Okay. So units will be newtons. So that is the lower bound. This is the upper bound. Now, as far as the angle is concerned, it is also rounded to the nearest integer, 1, right? So here also we have to add and subtract 0.5. So the upper bound will be 28.5 degrees and the lower bound will be 27.5 degrees, correct? So these are my values, possible values, which will give us the result for maximum and minimum horizontal force. Now when we are working in trigonometry, we need to really think which goes with what. That is kind of important. Now you can see this part. If the angle increases, right? So at present you can see the horizontal component is kind of this much long. But if I increase the angle, it becomes like this. The horizontal component decreases. So the value decreases by increasing angle. Do you get the idea, right? This is one way of checking. The other way for checking is we should calculate the value, right? So let us find the cos theta value for both, right? So what is the cos of 27.5 and what is the cos of 28.5? Let's figure that out, right? So let's find the cos values. So if I write cos of 27.5, I get what? I get 0.8870. In your calculations, you can use 4 decimal places. Okay. And how about cos of 28.5? 28.5 is equals to 0.8788. Correct? Clearly, you see that this value is smaller than this. Is that okay? So if I am writing the upper bound, which is kind of the angle on this side, the cosine value is lower. Do you see that? This value is lower than this. Do you understand that part? And this is the part which really creates a confusion when students are trying to calculate upper bound and lower bound for trigonometric functions. Correct? Now, let's get back to the question. So if I say I have to calculate lower bound for my horizontal component, which is f of cos theta, in that case, for the lower bound, which value of f should I take? Well, of course, the lower value, which is 214.5, right? So 214.5. Now, for theta, which value should I take? That's a big question, right? Since we saw that cos theta is lower for higher angle, we'll take 28.5 here. Do you see that? And then calculate the value. You get the idea, right? Now, for the upper bound, horizontal component, we have to take the higher values for force, which is 215.5 newtons times cosine of lower angle. The cosine value for lower angle is higher. Is it okay? If you see the curve of cosine function, let me sketch that also for you. Let me sketch a cosine function graph here for you. So it normally will be kind of starting with maximum, then going like this. So you can see that from 0 degrees to 90 degrees, it actually decreases from 1. Do you see that? It goes from 1 to -1, but it decreases in the first quarter of its cycle. Do you see that? So that becomes the maximum value which the horizontal force can take, right? Now we can use the calculator to calculate the answer, right? So we have 214.5 times cos of 28.5 is equal to, it is equals to 188 point, let's write down 2 decimal places, 506. So I'm writing 506 as 51. Okay. Now in this particular case, it is 215.5 times cos of 27.5 equals to 191.15. Do you see that? So the upper bound or the maximum value which this can take is 191, right? This is 189 if you round it to whole numbers, correct? So that's the kind of range which you can get. The units, of course, are newtons, right? So newtons, right? So that is what we've written to 2 decimal places. In case you need to write answers round to whole numbers, let's say nearest integer or round to whole numbers, then in that case the lower bound is equals to 189 newtons and the upper bound is equals to 191 newton. Do you see that? So that is how you can actually solve such questions. So in trigonometry, you have to see how to associate your values to really get the maximum. Do you see that? As in this case, we actually took the higher value of the angle to find the lower bound, right? So I hope that is important to understand and you appreciate it. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.